As many can attest, when you join the censored Earth community, you are given a new set of eyes. Now, I've studied Earth science before, but now that I've been given a new set of eyes, I'm going to go back and take another look and tell you what I see. This is Modern Earth Science Destroyed. Unit 1, Studying the Earth. Right off the bat, I've got to say I love the fact that they put the astronaut right next to the scuba diver. If you haven't studied about bubbles in space, I highly recommend doing so. I'll leave some links in this video's description and on our debate board.
Those clouds right there even look like bubbles. All right, let's continue.
Introducing Unit 1.
Communication is the key to progress in science. Without a way to build on past knowledge and pass new knowledge on to others, each new generation would have to rediscover facts about the planet on which we live.
I can't help but think of computers here, and imagine each generation having to reinvent the computer. Thankfully, we don't have to do that, but we are able to build bigger and better stuff when we are able to build off of other people's already existing inventions. This can be successful so long as it is built on a foundation of observation and experimentation. It is also important that the older generations are able to explain to the younger generations what they did so their experiments can be replicated. If the older generations can't do that and are merely passing on their assumptions, they are setting the younger generations up for failure. Continue on.
When I was a student majoring in urban and economic geography, I discovered one of our most valuable aids to scientific communications: maps. Maps are a delightful blend of art and science. They give us an efficient, graphic way to present volumes of knowledge in a single picture.
I hear the words of one of my art professors echoing in my mind. There is no man-made object in existence that is not related to art. That very much applies to every single field of science out there.
By looking at a map, you can view the world or part of it at a glance. By making a map, you can preserve your knowledge for future use. In this unit, you will discover how other Earth scientists use both words and pictures to communicate important information about our amazing planet.
Chapter 1. Introduction to Earth Science.
The natural world challenges our understanding with questions about why seasons change, rivers flood, and planets spin through space. Unlocking the secrets of the natural world takes Earth scientists to the rainforests of equatorial Africa and to ice caves such as this one in Canada. This chapter describes the origins of Earth science and some of the methods Earth scientists use to learn about the world around us.
That is some interesting wording right there. Why do you think the natural world challenges their understanding with questions about the seasons, floods, and planets? Do you think this is acknowledgement that real-world observations go against their beliefs?
Perhaps so.
Sometimes it feels like we've got a guy on the inside who has done a great job of dropping hints and making things easy for us.
Putting the astronaut next to the scuba diver was a good example of that.
As we read, let's see if we can't find some real-world observations that would challenge what they teach in here. Unit 1.1. What is Earth Science?
Since the beginning of human history, people have observed the world around them and wondered about the forces that shape that world. As early humans watched a volcano erupt, felt the earth tremble beneath them, or saw the moon darken during an eclipse, they asked why. To explain these natural phenomena, ancient people forged myths and legends, attributing such events to powerful supernatural forces. Angry goddesses hurled fire from volcanoes. Giants wrestled underground, causing the earth to shake. Not until people began to make careful observations and to search for natural causes to natural phenomena did the scientific study of the earth begin. The ancient Chinese, for example, began keeping written records of earthquakes as early as 780 BC. The ancient Greeks compiled a catalog of rocks and minerals in the 3rd century of BC. Other ancient peoples, such as the Mayas in Central America, kept track of the movements of the sun, the moon, and the planets. They used these observations to create accurate calendars.
Ooh, I have got to highlight that. That is common ground worth celebrating. I'm very glad to see that they acknowledge the Mayans' ability to make accurate astronomical predictions despite their differing worldview. In order to make an accurate calendar, you've got to be able to make accurate astronomical predictions.
At first, scientific discoveries were limited to observations made with the unaided eye. Then, in the 17th century, the invention of instruments such as the microscope and the telescope extended human observation to previously hidden worlds. Eventually, people accumulated an organized body of knowledge about the Earth, and the field of earth science was born. Earth science is the study of the Earth and the universe around it. Earth science, like other modern sciences, is based on the assumption that the causes of natural phenomena can be discovered through careful observation and experimentation.
Branches of Earth science.
As the technology for studying the Earth improved, the range of human observation increased dramatically. With the help of special equipment, scientists began to explore the dark ocean depths, the Earth's unknown interior, and the vastness of space. Their discoveries have created an immense body of knowledge about the Earth. Because one person cannot keep up with the developments in all areas of Earth science, most scientists today specialize. Currently, Earth scientists specialize in one of the following four major areas of study: the solid Earth, the oceans, the atmosphere, and the universe beyond the Earth. Career focus, a special feature that appears in each unit in this book, offers detailed information about careers in Earth science.
Yeeh, I can't say I'm a fan of the way that paragraph is worded. It sounds to me like they are trying to discourage those looking for a career away from looking at the big picture. It is as if they were saying, just focus on the small stuff, and let us tell you what the big picture is.
What do you think the big picture is that they are trying to get everyone to believe?
Ooh, look! The Legend of Eratosthenes.
Legend? Why are you calling the story of Eratosthenes a legend?
Let me show you. According to dictionary.com, a legend is a non-historical or unverifiable story handed down by tradition from earlier times and is popularly accepted as historical. As we read this, you'll notice that there are no references as to where this story came from. Seemingly, it is a story that has been repeated and handed down for generations without an original source document. With that being so, the authors of the book may as well be quoting from the Legend of Zelda in their effort to convince you of their claim that the Earth is a globe.
Okay. Though no one claims the Legend of Zelda is historical by any means, I can see your point. More than 22 centuries ago, a Greek mathematician named Eratosthenes used careful observation and simple geometry to determine the circumference of, or distance around the Earth. Eratosthenes read of a well in Syene, Egypt, modern-day Aswan, Egypt, where the sun's rays reach the bottom once each year, at noon on June 21st. Furthermore, the sun cast no shadows in Syene at that time. Eratosthenes thought these facts meant that the sun was directly overhead at Syene on June 21st. Eratosthenes knew that the sun did cast shadows in Alexandria, a city to the north of Syene, on June 21st, indicating that the sun's rays were striking that city at an angle. Eratosthenes determined that the angle of the sun's rays in Alexandria at noon on June 21st was 7.2 degrees. He thought that meant that the distance between the two cities was also 7.2 degrees, or 1/50th of the 360-degree circumference of the Earth. Eratosthenes knew that the distance between Syene and Alexandria was about 5,000 stadia, or 925 kilometers. By multiplying the known distance between Alexandria and Syene by 50, Eratosthenes calculated the polar circumference of the Earth to be 250,000 stadia, or 46,250 kilometers.
Did you notice how the authors never mentioned where this story came from? And how they never acknowledged this story as a legend?
Yeah.
Why do you think the authors felt the need to pass this legend down rather than point to a modern person who decided to perform this experiment?
That's a really good question.
All right, here's a mouthful. Let me tell you about argumentum ad antiquitatem, also known as the appeal to antiquity fallacy. The authors here are using a form of persuasion called an appeal to antiquity. Here, the authors are trying to get more persuasive power by implying that you should believe the Earth is a globe because that belief is really old. But just because a belief is old does not mean it is right. That is why it breaks the rules of logical thinking and is considered a fallacy. And if you think the age proves it right, please keep in mind the belief that the Earth is not a globe far outdates the belief that it is one. All right, now here is something else I want you to consider. Based on what we can see here, Eratosthenes began his experiment making two assumptions. First, he assumed he lived on a spherical Earth. Please note how we don't see any observation mentioned that would cause him to make that assumption. Did Eratosthenes have any photos of the Earth from space to persuade him into believing the Earth is a globe?
No. Although there are quite a few ancient alien theories out there.
Yeah, but I really recommend watching Ancient Aliens Debunked before you start watching Ancient Aliens. Oh, perhaps it was the observation of boats appearing to sink on the horizon.
One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake. The farther away a boat is, the more the bottom of the boat will disappear and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars.
But if the telescope wasn't invented until 1608 by Hans Lippershey, where did Eratosthenes get a telescope to make such an observation?
Very good point.
Now, Eratosthenes' second assumption here was that all the light from the sun was parallel. And again, we don't see any observation that he might have made to base that assumption on.
Yeah, I never heard the legend ever mention any kind of those details. Let's keep reading. With the aid of modern technology and sophisticated instruments, scientists now calculate the Earth's circumference to be about 40,000 kilometers. This value, which is considered accurate, differs from Eratosthenes' calculation of 46,250 kilometers by only 6,250 kilometers.
That is worth highlighting. Here, when they say scientists calculate, they are making a scientists say argument. It leads a person to ask, what scientists? Where? I don't see any references to any scientists anywhere mentioned here. Tell me, is it a good thing to trust an article that vaguely says scientists say?
Yeah, history is full of deceptive commercial advertising. It reminds me of many of the diet fads out there. Some of those have been really dangerous.
If anyone hasn't seen the documentary Forks Over Knives, it is a great one to watch about the history of the vague phrase scientists say and how it is commonly used in deceptive advertising. Please also keep the genetic fallacy in mind. We talked about this in the introduction. Just because a scientist says so doesn't mean they are right. We need to see the observations, not the person who made the observations. All right, now I want you to see this too. Here it says, and with modern technology and sophisticated instruments. They are saying that to metaphorically put a stethoscope around the neck of their unnamed scientists in order to get more persuasive power. They are arguing, we have technology, therefore you should trust us.
Yeah, a stethoscope is modern technology, but just because someone has a stethoscope around their neck, that doesn't mean they're right.
The appeal to technology is a form of the appeal to novelty fallacy. Or as C.S. Lewis described in his autobiography, Surprised by Joy, this is the chronological snobbery fallacy. Anyway, let's continue.
Suppose that city A is 3.335 kilometers north of city B, and that on June 21st, the angle of the sun's rays in city A is 0 degrees, while the angle of the ray in city B is 30 degrees. Use Eratosthenes' method to find the Earth's circumference.
How about we acknowledge the fact that the light from the sun is not parallel, and the fact that that ruins Eratosthenes' calculations. Now, as you know, I don't like the idea of just tossing their cake out the window and leaving our viewers with nothing on the table. Please allow me to provide a better cake that is backed by observation and experimentation. Observe, there are 3 kinds of shadow: umbra, penumbra, and antumbra. If the light from the sun were parallel, objects in the sunlight would not cast a penumbral shadow.
Yeah, I can see that.
So here is my shadow on a white fence.
Why does it look so blurry?
My camera isn't out of focus here. That blurriness around my core shadow is my penumbral shadow. Alright, I want you to see something real quick. Take notice of how the light is touching the Earth here in parallel rays. Got that?
Okay.
Now here's a timeanddate.com example of the light from the sun touching the Earth.
They're definitely different. They're not parallel like the other image.
They both can't be right, can they?
No.
So here in the observation of penumbra on our own shadows is a significant observation because it disproves Eratosthenes' assumption that all the light from the sun is parallel. And because my claim is backed up with observation and experimentation, I can say that my claim is more scientific than the one that they have there in the textbook. If anyone has a better cake that they would like to present, please share it on the debate board. There's a link in the description.
Okay, so why do you think they're teaching this? What do you think the author's motive was for putting this in the book?
It seems here that right from the get-go, the authors are trying to convince people that the Earth is a globe, and so far they have not provided any evidence to support their claim. On the cover of the book, you see a big picture of the globe with the enormous label Earth slapped on it. Then, in the introduction, we saw the Earth being described as similar to Jupiter with no further explanation. And now we see Eratosthenes' assumptions, with no grounds to support them and no acknowledgement that an assumption was even made. Here we can see all this effort going into teaching us the Earth is a globe, but so far it hasn't given us any substance to base that belief on. Now, if it continues this way, someday when someone challenges the reader and says the Earth is not a globe and provides some evidence to their claim, the reader is not going to have any substance to prove them wrong with, and they're just going to reach for every fallacy that's listed in the book. Now the question is, will the book continue to be this way? Let's keep reading and find out. Please forgive us as we skip over reading a little bit here, as the book covers some basic definitions for younger audiences.
Here the book covers the 4 primary topics in earth science: geology, oceanography, meteorology, and astronomy.
Alright, now the importance of earth science. This is a good area to look for the author's overall motives in writing this book.
Powerful forces are at work on the Earth. Volcanoes erupt and earthquakes shake the ground. These events not only shape the Earth, but also affect life on the Earth. A volcanic eruption may bury a town in ash. An earthquake may produce huge waves that destroy shorelines. By understanding how natural forces shape our environment, Earth scientists can better forecast potential disasters and help save lives and property.
Okay, I agree with that. A proper understanding of our world can save lives, and an improper understanding of our world can destroy lives. Another question I have to wonder about is, are the authors intentionally trying to pass along misinformation? Or are they just going with the flow and passing on what was taught to them?
Observations made by Earth scientists have contributed greatly to our knowledge of the world around us. For example, information gathered by astronomers studying distant galaxies has led to theories about the origins of this solar system. Geologists studying rock layers have found clues to the Earth's past environments and to the evolution of life on this planet.
Providing correct information in Earth science can give us a correct understanding of our origin, and false information can give us a false sense of origin. Now, how does that affect us, and why is that important? A fable is told about an eagle who thought he was a chicken. When the eagle was very small, he fell from the safety of his nest. A chicken farmer found the eagle, brought him to a farm, and raised him in a chicken coop among his many chickens. The eagle grew up doing what chickens do, living like a chicken, and believing he was a chicken. A naturalist came to the chicken farm to see if what he had heard about an eagle acting like a chicken was really true. He knew that an eagle was the king of the sky. He was surprised to see the eagle strutting around the chicken coop, pecking at the ground, and acting very much like a chicken. The farmer explained to the naturalist that this bird was no longer an eagle. He was now a chicken because he had been trained to be a chicken, and he believed he was a chicken. The naturalist knew there was more to this great bird than his actions showed, as he pretended to be a chicken. He was born an eagle, and had the heart of an eagle, and nothing could change that. The man lifted the eagle onto a fence surrounding the chicken coop and said, "Eagle, thou art an eagle. Stretch forth thy wings and fly." The eagle moved slightly, only to look at the man. Then he glanced down at his home among the chickens in the chicken coop, where he was comfortable. He jumped off the fence and continued doing what chickens do. The farmer was satisfied. "I told you he was a chicken," he said. The naturalist returned the next day and tried again to convince the farmer and the eagle that the eagle was born for something greater. He took the eagle to the top of the farmhouse and spoke to him. "Eagle, thou art an eagle. Thou dost belong to the sky and not the earth. Stretch forth thy wings and fly." The large bird looked at the man, then again down into the chicken coop. He jumped from the man's arm onto the roof of the farmhouse. Knowing what eagles are really about, the naturalist asked the farmer to let him try one more time. He would return the next day and prove that this bird was an eagle. The farmer, convinced otherwise, said, "It's a chicken." The naturalist returned the next morning to the chicken farm and took the eagle and the farmer some distance away to the foot of a high mountain. They could not see the farm nor the chicken coop from this new setting. The man held the eagle on his arm and pointed into the sky, where the bright sun was beckoning above. He spoke, "Eagle, thou art an eagle. Thou dost belong to the sky and not the earth. Stretch forth thy wings and fly." This time, the eagle stared skyward into the bright sun, straightened his large body, and stretched his massive wings. His wings moved slowly at first. Then surely and powerfully, with the mighty screech of an eagle, he flew.
I really like that. Having a correct understanding of our origin really helps us have a better understanding of what we can do and what our true potential is.
I know I can testify that there are very real powers that should not be, who want us to forget about who we are and where we came from. I often share my videos around on Facebook, and in a group overrun by trolls, someone once commented saying, "Who do you think you are? You aren't special. There's nothing special about you." My response to them was, "Oh, I know who I am. The question is, who are you? Because you sure don't sound like Mr. Rogers right now."
The Earth also provides many valuable resources that enrich the quality of people's lives. For example, the fuel that powers a jet, the metal used to make surgical instruments, and the paper and the ink of this book all come from the Earth. The study of earth science can help people gain access to the Earth's resources and teaches them to use those resources wisely.
And herein is another reason why someone might want to spread some misinformation. If I were a corporate CEO like Andrew Carnegie in the oil industry, who had some strong influence in academia, I might be tempted to use some of that influence to throw competitors off of my trail. Ecology.
I am just going to summarize this. Ecology is the link between biology and earth science. It is the study of the different ecosystems. The biggest ecosystem is the biosphere, and within that, there is the geosphere, hydrosphere, and atmosphere.
As we better understand ecosystems, we are better able to understand the way pollution affects the world around us. This helps us bring problems to our attention, because problems that are out of sight and out of mind do not get fixed.
Everyone just needs to be responsible.
Oh, and come on guys, don't be so vague. If you're going to say meteorologists found something, please provide a reference for the actual people who discovered the thing.
Our future generations need better than that.
Alright, so Earth science is important for the sake of protecting ecosystems. Now, if that is the case, how does telling people we live on a globe fulfill that motive? Here I have turned the concepts the authors presented into a concept map, as the book described in the introduction. Please notice how astronomy doesn't seem to connect to one of the things studied in ecology. Do you think it should? If so, where should it connect? I'll leave that one open for the audience to come and discuss on the debate board. Now, if your primary objective was to protect and enhance the environment, would dumping obscene amounts of money into astronomy be considered a misallocation of funds? That is another question I would love to talk about on the debate board.
Whoa, wait. Before we move on, I gotta ask, why are there so many spheres here? Like biosphere, geosphere, hydrosphere, and atmosphere. Are they implying that the Earth is a ball?
Let's open the dictionary on that one. Ah, here we are. Sphere, the place or environment within which a person or thing exists.
Okay, biosphere, geosphere, they're all talking about the places where life exists. I understand that. Thank you, dictionary.com. I just felt the need to clarify that. Okay, let's try and end this on a positive note. As we study the Earth, its intricacy, organization, and beauty, it is easy to see that not one of us is insignificant. In the big picture, we are all important, and every one of us is special. And we'll leave you with that. Thank you for watching.
I look forward to our next lesson. It will be about the scientific method.
You plan on destroying that?
It'll be an interesting lesson for sure. I hope you'll join us.
I think I'll make a snappy new day. It's such a good feeling, a very good feeling, a feeling you know that I'll be back when the week is new, and I'll have more ideas for you, and you'll have things you'll want to talk about. I will too.